Okay, let's start a senior high school maths, session 4. Okay, first question. A loan of 6,000 is to be repaid by equal annual installments. Compound interest. Calculate yearly is 9% per annum. If the annual installment is the $N, first one A. If the $6,000 is exactly repaid at the end of the N years, write an expression for the annual installment. Okay, we just do the A1. Since A1 means at the end of the first years, okay, 6,000 is principal here. Then plus this 6,000, the bank will charge interest at the 9%. Then times this is the 0.09. Then this is the 6,000. I move the 6,000 outside, factorize. Times is the 1.09. Okay, this is A1 is at the end of the first year. Okay. Okay, this the first one to the A. So this A1 means at the end of the first year, the balance. Okay, 6,000 is here. And then this 6,000 will be charged interest, 0.609. But at the end of the each year, so the person will pay the installment. Okay, so this is the balance of owning at the end of the first years. Then continue, this will be equal to 6,000. I can move outside. So this will be 6,000 times is the 1.09 minus is the $N. Okay, so this is the A1. At the end of the first year, the balance owed to the bank. Okay, I write this is A2. This A2 means at the end of the second years. Okay, will be equal to this A1, the balance. This the end of the first year, the balance will be brought to the second year, beginning of second year. A1 plus this A1 will be charged the interest. Then take away at the end of the second year. So installment payback, this one. Then this will be equal to this A1. I move the A1 outside, then times is 1.09 minus is the $N. Okay, then equal to A1. A1 is this one, A1. Okay, I'm using the A1 to replace it here. See the 6,000 times is the 1.09 minus the this A1 times the 1.09. Okay, this one will be equal to this 1.09 I explained. So this times this will be equal to 6,000 times this 1.09 square. Then minus this one times this. 1.09 times the 6. Then minus the, okay, continue equal to, okay, the 6 will be the 6,000 times the 6, the 1.09 theta square. Minus, I move the $m outside. This will be 1 plus this is 1.09. Okay, so the A1 is this one. A2 is this one. Then I can write the AN. So the AN at the end of the system N years will be equal to, using this pattern. Using this pattern, I can write this 6,000 times this 1.09. This is the 2. And this is the 2. This is the N, so I put this is the N. Okay, so minus is the dollar, this is the M. This is the 1 plus this is the 1.09 plus plus this is the 1.09. What is this power? If this is the 2, this is the power 1. So now this is the N. So this is the last term. Must be the sixth one. Okay, at the end of the N years, the balance the sixth one. So the question said, if the 6,000 is exactly repaid at the end of the N years, okay. So in this case, it means the balance will be equal to 0. Okay, when this at the end of the 6 N years, so pay off the 6 loan. Okay, so I just make they want me find the installment, the $M. Okay, so this AN are using the 0 to replace. So now, so means the 6,000 times the 6. Plus the system plus the system 1.0 system 9 system n system minus 1. And then this is equal to 0. Okay, now so system m. System m. So must be equal to 6,000 times system 1.609 system n. Then bottom is 1 plus the system 1.09 plus the system 1.09 system square. Then plus the system dot plus the system 1.609 system n system minus 1. Then continue equal to okay, the system m equal to, since the top is 6,000 times this 1.09 system n. The bottom is a geometry series. Common ratio is the 6 divided 6, 1.09. Okay, then I using the geometry sum. Okay, then will be equal to, this is the R minus 1. This is the A. theta r power n minus theta 1. Okay, then equal to 6,000 times theta 1.09 theta n. Okay, bottom. What is the common ratio? Common ratio is 1.09. Okay, 1.09 minus 1 is 0.09. And theta A is the first term. First term is the 1. Okay. Then 1 times theta R is 1.09. How many terms here? The this 1 is the this means 1.09 power 0 to here. So altogether here is n term here. So I just put 1.09 n term theta minus theta 1 here. Okay, so now it will be equal to theta 0.09, I can jump to the top. Okay, then will be equal to 0.09 times the 6,000 times 1.09 theta n. And the bottom is the 1.60 theta 9 theta n theta minus 1. Okay, so we finished the first one. Have a look at that again. Okay, the first one. The first one is the question we want to ask. Expression for the annual installment. Okay, so I already have expressed. This is the annual installment is this one here. So the next one. Okay, so the next one. So the next one is they say calculate the annual installment $M where n equal to 25. Okay. B where n equal to 25. Okay, so see the dollar, see the M. Yearly installment will be equal to 1.0925 minus 1. Set the n using 25 to replace. And 0.609 times the 6,000. Then times the 1.09 set n 25. N using 25 to replace. Then equal to 0.09 times 6,000 times the 1.09 power 25. Bottom is the 1.09 power 25 minus 1. Okay, so the yearly will be paid 600. Okay, what's this amount for? Okay, so if I borrow 6,000 from bank, okay, so the bank will be charged the 9%. So how much are we paid yearly? Then when the term is 25, so at the end of the 25 years, the balance is 0. So every year I pay $610.84 every year. Pay this amount for 25 times. Then I pay off the this loan. Okay, I finished this question here. Then we have looked at the next extension 1 question. Okay. So this one, so without solving the equation, So now solving. So how many solutions are there for the system x between 0 and 2 pi? Okay. In this type of the question, I have to draw theta y equal to sine 2x. I have to draw this one. Then I also have to draw the y equal to half. Okay, so now I just draw the theta y equal to sine the 2x. Okay, if the theta y equal to theta sine theta 2x, I want to draw this one. Okay, so I have to find the period here. Period equal to the 2 pi divide x from digits 2, divide 2 equal to pi. This means that every pi, then this curve will be repeating. Okay, so now I just draw this curve. I think maybe I just draw this side. Okay, so I just draw this one. Okay, every pi will be repeating. So theta pi. So 1 point, 2 point, 3 point, theta 4, theta 5. Okay, theta pi on 2, theta pi on 4, and theta 3 pi on 4. Okay, so 1, I just put the 1 here. Then theta minus 1. Okay, so when x equal to 0 is 0. Okay, the curve is going to 6. And then see. Okay, I draw another repeating pi, theta 2 pi. Because the question they give us domain is from 0 to 2 pi. So I have to draw up to 2 pi. Okay, this one will be theta 3 pi on 2. Okay, the 6 plus the 6. 180 plus the 270 divided by 2. 2 to 5. Okay, the 6 point is theta 5 pi on 4. And the 6th one is the 7 pi on 4. Okay, the 6th one is 0, so theta 1. And the 6th, and another point here. Okay, so I already draw the y equal to sine the 2x here. Then I also have to draw the y equal to half. So y equal to half. Half is here. Okay, this is the 1, this is the half. Okay, so they are equal. Y equal to half. And then y equal to sine the 2x. How many solutions? They intersect at 1 point, 2 point, 3 point, theta 4 point. Okay, so sine the theta 2x, this curve is the y equal to theta sine 2x. Then this curve, the y equal to half. Okay, I just draw theta 2 curve. See how many they meet. Theta 2 curves meet at the theta 4 point. So I can answer. So how many solutions? So this is the 4 solution. Okay, finish this question. I even do not need to solve. So I just draw the 2 curve because the question says without solving. So I didn't do the solving. I just draw the y equal to sine the 2x. Then draw another one, y equal to half. Oh, I can find the they have the 4 intersection, means they have the 4 solution. Okay, so now I do the last question. Okay, so the question find the integration. So they given the this Rn equal to integration from the 0 to pi over 4 tangent theta d theta. This n is all integer, positive integer. Okay, first one, I1. Theta I, theta 1, then equal to theta 0. This is pi over 4. Okay, the question is this must be the n here. Okay, so I1 is equal to 0 to pi on 4. And since the n is 1, so means the tangent, since the theta, since the n is 1, I don't have to write, so d theta. Then equal to theta 0, so theta pi on 4. Tangent theta is theta sine theta. And this one is the cosine theta. Okay, then equal to theta minus theta 0, theta pi on 4. Theta minus theta sine theta on cosine theta. Okay, then equal to, okay, top is the, if I do the bottom derivative, cosine theta derivative is a minus sine theta. So the top is the derivative of the bottom. So this must be equal to minus theta log the theta bottom is the cosine theta. Okay, then equal to minus log the cosine theta. Cosine theta is equal to 1 on root 2. Then minus sub the 0. Cosine 0 will be 1. Log 1 is 0. So minus theta 0. Okay. And this one will be equal to minus theta log the theta 2 theta minus theta half. Because the theta 1 on root 2 is equal to 2 power minus the half. Okay. Okay, so now it's equal to theta power minus half, I can move to the front. So minus times minus half, positive half. Okay, so now I finished the theta A. Now we do the B. So the question is required to show. This show okay, so theta I, theta N, plus the theta I, the theta N, theta minus 2, then equal to theta 1, theta n, theta minus theta 1. Okay, so In means the integration 0 theta pi on 4 tangent theta n theta d theta plus the 6 n minus 2. Okay, so theta 0 theta pi on theta 4. Okay, so this is the tangent n minus 2. This n minus 2 here means this is n minus 2. So theta n theta minus theta 2 d theta. Okay, then equal to 0 theta pi on 4. And theta tangent theta n theta plus the theta tangent theta n theta minus 2 theta d theta. Okay, then equal to 0 theta pi on 4. Okay, I can move the tangent theta n theta minus 2 theta outside. Then the this one, I move the theta n minus 2. So means theta tangent theta squared theta still here. And this one, I move outside with theta plus theta 1 d theta. Okay, then equal to okay, this one is equal to theta integration theta pi on 4. Okay, theta tangent n on 2 theta still here. 1 plus tangent square theta is equal to sec squared theta. Okay, then this one is equal to this. I can put the theta, the tangent theta. So when you do the derivative, the tangent theta, so we will give you theta sec squared theta d theta. This part is equal to the this part. Okay. So now I can do the integration. So this integration will equal to tangent theta n power plus 1. Okay, then equal to, I'm using the theta, using the pi on 4 to replace. Tangent 45 will be equal, tangent pi on 4 is 1. So the top is 1. Then minus theta using 0 to replace is 0. Okay, so the question, so need us to show In plus this In minus 2 equal to this, which I already show. I start to see the left-hand side. In is the this one, plus In minus 2 the this one. Then I continue do, I can get the this one, okay. So need to ask the show, I already show. So now do the C. Okay, so far I already show. Okay, so I already have this one. In plus In minus 2. Okay. We already show In plus system I system n say minus 2, then equal to 1 on system n minus 1, which we already show here. In plus in minus 2 equal to 1 on n minus 1. Okay, I already showed this one. So now I need to do the C. C is I need to find the I5. So need to find this one. Okay. Okay, so this I5, so need to find, okay. So now from here, In equal to 1 system n minus 1 minus system I system n system minus 2. We already proved this one. Then In, this move to right hand side, coming to this one. Okay, now I5, if when n equal to 5, must be equal to 1 on n using the 5 to replace, it's a 4. Minus is the In is a 5. 5 minus 2 is a 3. Okay, then continue. Then I5 equal to the 1 on 4 minus I3. I3 are using this one formula here. I3, so this n is 3, this n 3 will be the 1 on 3 minus 1 is 2 minus the 3, n using the 3, so I1. Then equal to 1 on 4 minus this, take off the scissor break, minus the half, plus the sister I1. Okay, then continue equal to 1 on 4 minus the half will be minus quarter plus I1. I1 we already have before. I1 is this one, half. I1 is the positive half. Since I1 is equal to minus, this the minus half can move to the front. It's positive half log the 2. This the I1, okay. Okay, I1 is a plus, this is the half log the 2. Okay, we finish this question here. Yeah. So the first one found I1, I already found I1. Next one B. So need to show In plus In minus 2 equal to 1 over n minus 1. So the need to show since In plus In minus 2 equal to this one. Then I already showed this one, show. Next one, so need to find I5. I5, so this the formula we already show. So I just this In equal to, I move the this to this side, I come into this one. Now I5, so n using the 5 to replace 5. N using 5 to replace. N using 5 to replace, coming to this one. Then equal to 1 on 4 minus I3, I'll do another one. So this time I3, n using the 3 to replace. 1 on 3 minus 1 is a half. 3 here is minus I1, then equal to 1 over 4 minus a half plus I1. I1 we already did this before, so plus this one. Okay, we finished the question.